A cyclist traveled 8 kilometers in 20 minutes, moving at a constant speed. At the same speed, how far would the cyclist travel in 2 hours? So, as we know, speed is equal to distance over time. So, in this case, the distance is 8, and the time, I'm going to convert it to hours. You don't have to, but I will. So that is 24. That is 24 kilometers per hour. So now they want me to figure out how far. So they want me to figure out distance. So that formula, we have to modify it to s times t. The speed is 24. The time is 2. So that's 48. And it would be 48 kilometers. If the square root of x plus 5 is 5, what is x? X plus 5 square root is 5. Square both sides, and we get x plus 5 is 25. And subtract the 5, and we get x equals 20. The digits a and b make up the multiplication below correct. What is a plus b? So a little bit of thinking here. We have 2a7. What that really is 200 plus 10a plus 7. And then we have to multiply this guy by 3. Okay, so just if you do it directly, it would be 600 plus 30a plus 21, right? But if you notice, the end result is not 600 something, it's 700 something. So that means that this a is probably made that 30 multiply a few times. So let's experiment a little bit. See, I'm not sure. If a is 3, which is what I think it is, just based on, which is a very quick observation, it would be 600 plus 90 plus 21. Let's see what that is. That would be 711, right? Yeah, so that matches. So that means that b would be a 1. And then what are they asking for? A plus b. That would be this 3 plus 1, which is 4. So Euclidville Transit charges $3.25 for a single ride on a train. They also sell a 1-month pass for $90. That allows the pass holder to ride the train as many times as they want during the month. Marcy plans to ride the train K times in the month of May and determines that she will spend less money if she buys a $90 pass. What is the smallest possible value of the integer K? Well, 90 has to be less than 3.25 times K, right? Because K represents the number of times. And that scenario, if you're just paying per ride, it's 325 per ride. But the pass is going to be less money. Let me see if I interpreted that question properly. She will spend less money if she buys a 90. Okay, so yeah, this is correct. So I guess we're just solving this inequality. So it would be 90 divided by 3.25. So therefore K has got to be greater than, and this is going to be about 27.7 approximately. So now K is an integer. So K is going to be either 28, 29, and so on. And they want the smallest. So the smallest, of course, is the 28. 7 identical square pieces of paper were labeled with the letters A through G. These papers were then placed on a table one at a time, in some order, ending with the paper labeled E. The diagram shows the view from above. In what order were the papers placed on the table? Okay, so let's see here. Let's go with the obvious. I think E was placed last. So last, and I think that's fairly obvious because it's sort of, you can see all of it. So because you can see all of it, no other page was placed on top of it. I think that's the most obvious one. Now we got to think here. I think the second last, and I'm going backward here. Instead of going first, second, third, I'm going last, second, last, and so on. I'm pretty sure G is the one because G, as you can see, if E was not there, you would be able to see all of it. Yeah, so E covered it, so that had to be the second last. And then before E, before G, I think it's F. So that's third last. Yeah. For the same reasoning. Because F looks like it's covering D. Yeah, so let me actually, to explain this a little bit better, let me just write what each one covers. Well, a lot of them cover multiple, but what they cover sort of immediately. This one is obviously covering, well, it's covering a lot, but it immediately covers G, and that's why I put G here. G is immediately covering F, and that's why I put F here. F looks to me like it most likely covers a lot, but it looks like it immediately covers D. So the D is going to go here as fourth last. D looks like it covers B in terms of the one it immediately covered when it was placed, the first one that it was laid on top of. Okay, so I think I'm okay so far. FDB, let's see what's next here. After D, I think, well, B. Yeah, that'll be fifth last. And B covers, let's see here, oh boy. A would be my guess, since A looks like it's bigger. So then A goes here, and then A covered C. So C is the seventh last or first. Yeah. So the order would be, in terms of first to last, C, A, B, D, F, G, E. C, A, B, D, F, G, E. Yeah, I'm pretty confident that is the order in which the papers were placed. Two lines with the equations 2x minus 6y plus 42 is 0 and 15x plus ky plus d is 0 are perpendicular and intersect at a point on the y-axis. What is the value of d? All right, 2x minus 6y plus 42 is 0. And this is perpendicular, that's the symbol, to 15x plus ky plus d is 0. Now, I guess we just have to work with these here. This one here, first I'll divide through by 2. Make it a little bit easier here, and then put it in that y equals mx plus b form. You remember that y equals mx plus b form? So basically I isolate for y. So x plus 21 is 3y, and therefore y is equal to 1/3 x plus 7. Okay, that's, I mean, I'm assuming that's a good start, and this is my slope, m1. Now, since this line is perpendicular to that line, this line would have the slope that is the negative reciprocal. Negative reciprocal of this slope, which is 1/3. And the negative reciprocal of 1/3 is minus 3. So that will be the slope of this line right here. Okay, so what I'll do is, again, I'll convert this into this form so I can make a direct comparison. So let's see, that would be ky is equal to minus 15x minus d. Y is equal to minus 15 over k, x minus d over k. So this is the M2. Okay, so minus 15k is equal to minus 3. So that means k is equal to 5? Yeah, k is equal to 5. Okay, what do they want? Oh, they want the value of d. Okay, so I'm not yet done. How do I get the value of d? They intersect on the y-axis. Okay, so let's just draw a little graph here. The first equation, this guy, I have no idea what it looks like, but let's just say it looks something like this here, where it passes through 7. That much I know if you substitute 0 for x. And the second line, most likely, well, again, I don't know what it looks like, but it passes through that point according to the question, right? So the second line, something like that. It intersects on the point on the y-axis. So that point, which is 0, 7, is common to both lines. So because it's common to both lines, it would satisfy both equations. So this equation up here was y is equal to, since k is 5, minus 3x minus d k, and k is 5. Okay, so then I just have to substitute this point. So substitute 0, 7, and we get 7 is equal to minus d over 5. So therefore that means d is equal to minus 35. Ashwin chooses a 2-digit integer x and reverses the digits of x to obtain a larger integer y. He notices that y minus x is 18. How many possibilities are there? Let's see here. let's call the integer AB, and that's x. So therefore, y would be equal to b8. Now, what this really is 10a plus b. And this is, of course, 10b plus a. Right? Because the number 79 is equal to 10 times 7 plus 9. Correct? That's why I have this format. And then they're saying that y minus x is 18. So y minus x is 18. So therefore, that would be 10b plus a minus 10a minus b is 18. So that looks to me like 9b minus 9a is 18. Divide through by 9, and we get b minus a is 2. Okay, so then we can make a little table, and off we go. So let's see here. We'll make a b, an a, and then what are they asking for? X. So x is ab, so then ab. Okay, and concentrating on this formula, b minus a. So they're digits, so they can be only from what, 0 to 9. So let's start with the biggest one. So 9 and 7, then 8, 6, and so on, right? This is a fairly straightforward list to make. 4, 2, 3, 1, and oops, sorry, 2, 0. Now let me just see here. I can't go anything lower than 0. This is going to be 79, this is going to be 68, 57, 46, 35, 24, 13, and 02. But here's the thing. This is not a 2-digit integer, so that one won't work. So the only ones that we can include are these guys here. So how many possibilities? 1, 2, 3, 4, 5, 6, 7. So 7 is the actual answer for this question. In triangle ABC, angle ABC is 90, AB is 3, BC is 4, AC is 5. Point D is on AC, so that triangle ADB and triangle CDB have the same area. What is the length of BD? All right, well, I tend to do this a lot, put it on a coordinate axis. It always works, so that's why I keep doing it. Okay, so first of all, let's figure out the area of the entire triangle ABC, triangle ABC. 1/2 base times height, right? The base is BC, which is 4. The height is AB, which is 3. So it'll be 4 times 3. So that's 6. And therefore, since the triangles ADB and CDB have the same area, they're going to be 3 each in terms of their areas. Okay, at this point, I think I'm going to draw 2 lines. One that goes like that represents sort of the height of that triangle, and one that represents the height of that triangle. So I'll explain what I mean. So D needs coordinates here. We're going to call them AB. So therefore, if you look at the first triangle, ADB, it is 1/2 base times height. The base is 3, and the height is that red line that is horizontal, and that's represented by A in my question. So there you go. And ADB is 3. So 3 is equal to 3 over 2A, and therefore A looks to me like 2. In a very similar way, we'd figure out the area of the other guy, which is what? CDB. CDB. And that's also, of course, 1/2 base times height. The base is times 4. The height is represented by the letter B in my diagram. So that's 3 is equal to 2B, and therefore B would be 3 over 2. Okay, so what are they asking for? The length of BD. The length of BD. Okay, using Pythagoras, BD squared would be A squared plus B squared, correct? So BD squared would be 2 squared plus 3 over 2 squared. And therefore BD squared would be 4 plus, is it 2.25? I'm combining fractions with decimals. And then BD would therefore be the root of 6.25, I believe. And that is 2.5. Zin rolls a fair 8-sided die with sides numbered 1 through 8 and a fair 9-sided die with sides numbered 1 through 9. What is the probability that the product of the numbers rolled is divisible by 6? The product, let's just say the 8-sided die, 8-sided die, that you roll a number that's represented by 8. And the 9-sided die, we roll a number that's represented by B. So their product would be AB, and they're saying that's a multiple of 6, so 6K. Okay, and K is an integer. K is an integer. All right, and the probability is going to be something, well, the top is our specific condition, which is that AB is equal to 6K, and the bottom is the total. And the total is the easier one to figure out. For A, we have 8 possibilities, right? 1 through 8. And for B, we have 9 possibilities. So the total would be 8 times 9. That's all of the possible combinations. But the probability, of course, we will have to figure out that specific condition, that number. And when we do, then we can get the probability. Okay, so I don't think there's any sort of trick here. I think you just have to kind of manually crunch this out. And I'll explain what I mean by that. I'm going to need some space here. Yeah, so let me just explain what I'm doing here. So here I'm going to write the value of K, here the product, and then the possibilities for A and B, and then the number of cases, and then we have to add them all up. So I'm going to need a lot of space, so let me just, yeah. Okay, here we go. When K is 1, AB would be, well, let me just put that, let me put that in the field here so you kind of know what I'm doing. I'm going to put that there. AB is 6K, right? So if K is 1, this is 6. So what are the possibilities? You have 1, 6, 2, 3, 3, 2, and 6, 1. So we got four possible cases there. And this is really how we're going to do it. We're just going to crunch these out manually. I really don't think that there's a faster way. If there is, then you can definitely do it the faster way. So 3, 4, and 2, 6. So this is 4. So far we got those. If K is 3, this is 18. 2, 9, 3, 6, and 6, 3. Now keep in mind you can't do 9, 2 because the first die only goes up to 8. So just be careful there. Some of you might be tempted to put a 9, 2. Since this was 2, 9, that's only 3 there. Okay, if 4, 24, 8, 3, 6, 4, 4, 6, and 3, 8. So we got another 4. And let's see what's next here. Let's just keep going. If it's 5, then this is 30. And I think 6, 5, and 5, 6 are the only ones. So there's 2 there. If it's 6, this is 36. And I think 6, 6, and 4, 9 are the only ones. So there's 2 there. If it's 7, this is 42. So 7, 6, and 6, 7. So there's 2 there. If it's 8, we have 48. And I think 8, 6, and 6, 8. So there's 2. And 9 is 54. So 6 and 9. So there's only 1 there. And then 10 would give you 60. And I don't think there's anything you could do there. 11 would give you 66. Again, no possibility. And then the last one is 12. That's 72. And that's the last one. 8, 9. So there's 1. So now we got to add these up. 4, 4, 3. That's 11, 15, 17, 19, 21, 23, 24, 25. So all of these guys, all of our cases, add up to 25. So 25 is what goes here. So I guess we have to make this into a fraction. It would be 25 over 72. And I believe that is already in lowest terms. So that is the probability. How many ordered pairs of integers a, b satisfy both a plus b is greater than minus 23 and a times b is 120? All right, so this one is what I'll look at first. If a times b is 120, let me list out the divisors of 120. There's a lot of them. And it's always going to be plus or minus. So plus or minus 1, 2, 3, 4, 5, 6, 8, 10, 12, 15, 20, 24, 30, 40, 60, and 120. So how many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And there's plus or minus, so it's a total of 32 divisors. Okay, that's a lot. Okay. All right, so I think, again, very similar to the last question, I think we just have to manually crunch these out. Like that. What is it greater than? Okay, but the good news is that this is greater than minus 23, right? So let me just deal with the positive one, and then we'll deal with the negative stuff later. And it makes it a little bit easier to kind of break it up like that. If the choices that I have for A and B are both positive, then this will definitely be positive. So for example, if this is 1, this would be 120, and A plus B is obviously 121, which is obviously greater than 0. So that's going to be true for all of them. Everyone is going to have a matching pair all the way down to the last one, like that. So this is how many? 16, right? Yeah, 16 positive divisors. So all of those are going to be satisfying this equation right here, this guy. Okay, so then we will look into the negative ones. So these were the positive divisors. Now let's look at the negative divisors and see what kind of a story we get. And then you just have to kind of crunch through these to get any that would give you greater than minus 23. And when you brainstorm this list up here, this list up here, and looking just at the negative numbers, you get that the only ones that actually fit are minus 10 and 12, because that would give you minus 22, which is greater than minus 23. And if you flip the minus 12 and minus 10, that would also give you minus 22, which is greater than minus 23. And that's it. Those are the only possible combinations using the negative divisors. So this gives you another 2. So if you add these, you get 18. And 18 is actually the answer to the question. The quadratic function with the equation y is equal to minus 2x squared plus 4kx minus 10k has a maximum of 48. What is the sum of all possible values of k? Okay, so we have some parabola, and because the coefficient is negative, it points downwards. And I don't know what it looks like, but it looks something like that, right? Or that's the x value, and that's y, x-axis. And the maximum is here. So this is the max, and they're saying that's 48. And then obviously it corresponds to some value of x. Now, in order to do this question, in my opinion, we need to have the equation in this form. And some of you may recognize this. Y is equal to a x minus h squared plus k. And if it is in that formula, what it means is that when x is equal to h, the max is k. And that's assuming that it points downwards. If it points upwards, then it would be a minimum, right? If a is less than 0, I believe. Yeah, if I did that, hopefully that's the right way of, yeah. Okay, so we have to change that equation into this form. And how do you do that? Well, you do that by doing something called completing the square. And some of you know how to do this, and I'll walk you through it. So we have y is equal to minus 2x squared plus 4kx minus 10k. Okay, so the first thing you do is you have to factor out this minus 2. So I get x squared minus 2kx. And then this minus 10k, just leave it alone for now. You don't need to worry about it. And then now we get to completing the square. So how do we do that? You take this coefficient right here. So I'll do it on the side here. That's the coefficient, right? Minus 2k. You take half of it, which would be k minus k, and then you square that, and that would become k squared. And then you go back and you take that and you add it and subtract it. And the reason you do that is then that allows you to factor those three terms. And it factors very nicely. In this case, it would be x minus k. Got it? And then don't forget that this and this has to be kicked out of the bracket, and it would be 2k squared, I believe. Okay, so let me just see if I did that right. Y is equal to minus 2, x minus k squared. Yes. Okay, so then now we use the fact that the maximum is 48. So basically what that means is that when x is equal to k, the max is 48. So when x equals k, this equation just reduces to those guys. So when x is equal to k, that means that 48 is equal to 2k squared minus 10k. Got it? And this should be solved fairly easily, hopefully. 2k squared minus 10k minus 48 is equal to 0. Divide through by 2k squared minus 5k minus 24. And I hope this factors. Let's see. k 8, 3 minus positive. Yeah. So k is either equal to 8 or minus 3. And what do they want in this question? What is the sum of all possible values of k? Okay. So the sum of those guys are 8 plus minus 3, and that would be 5. The integers a, b, c, and d have the following properties. A is equal to 5 over 2 times the average of a, b, c, and d. B is equal to 4 over 5 times the average of a, b, c, and d. And c plus d is 140. What is a plus b plus c plus d? So this one is going to be helpful. This guy and this guy. So one, in terms of a math equation, would be a is equal to 5 over 2 times a plus b plus c plus d over 4. And 2, in terms of an equation, would be b is equal to 4 over 5 times a plus b plus c plus d over 4. And then if we sub this guy in, that would make it, let's see here. I'm going to actually go ahead and multiply through by 8. 5 times a plus b plus 140 for 1, the equation 1. Equation 2, I'll go ahead and let me think about this for a second. Well, this 4 would cancel with that 4, so that would multiply through by 5, I guess. So 5b is equal to a plus b plus 140. All right. Okay. Where do I go from here? I guess it's just 2 equations and 2 variables, so I guess just solve for them. Yeah, I can't think of any other way of doing this. So first I have to clean this up a little bit. So for 1, it would be 3a is equal to 5b plus 5 times 140, right? And then, therefore, if I isolate for b, it would be 3a minus 5 times 140 over 5 is b. Yeah, and then I can just substitute it back into this formula. And I think that should work. Okay, so let's do that. And I guess I'm just going to use 2. So b, well, b is 3a minus 5 times 140 over 5. And that is equal to this guy here. So it's a plus b plus c plus d, which is 140, all over 5. So that equation is what I will use to solve. But I've got another b in there. Oh, okay. It's not as easy as I initially thought. Okay, so let's first of all, let's get rid of the 5s. Can I do that? Let me go back and see if I did this right. Yeah. Yeah. So 3a minus 5 times 140. I can get rid of the 5s, and then a plus b again. So 140, and then the b is 3a minus 5 times 140 over 5. All over 5, actually. Okay. All right, so this now becomes... This and this are very similar. This and this guy and this guy. So if I put everything on one side, it would actually be 4 over 5, 3a minus 5 times 140. And then this is just the a plus 140. Okay, moving right along. Multiply through here, and this will be 12a minus 20 times 140, and then multiply that by 5, that side, plus 5 times 140, like this. So this looks like 7a is equal to 25 times 140, and then divide through by 7, and you get 25 times 20. So a would be 500. Okay, and then substitute that a back into one of these guys here, this guy here. So b would be 3 times 500 minus 5 times 140 over 5. So that's going to be what, 3 times 100 minus 140. So that's 300 minus 140, so that's 160. Okay, so I got A, I got B, so I think I'm ready to do this. So A plus B plus C plus D, which is what they wanted. A is 500, B is 160, and then C plus D, that's just 140 from up there. So this looks like it's 800. What is the value of n for which 3 to the power of 8 plus 3 to the power of n over 3 squared plus 3 to the power of n, all cube rooted, is equal to 3? Okay, let's see what we can do here. So, well, the first thing is the 3 to the power of n, I'd like to kind of substitute that as a. You don't really need to, but it just makes it a little bit easier. The first step, of course, is to take the cube of both sides. That gets rid of that cube root. So this just becomes this, and then this becomes 3 to the power of 3. And then let's make the substitution. So 3 to the power of 8 plus a, 3 squared plus a, and I believe that's 27. Okay, so now I think this will be a little bit more digestible, and I'm going to need a little bit of space here. So 3 to the power of 8 plus a is equal to, let's see here. Let's keep it in powers of 3. I know I converted it, but let me convert it back. I think it's easier to use powers of 3 than to get the big number. So this will be 3 to the power of 5 plus 3 to the power of 3 times a. Okay. Now let's put all these guys on one side. Times a minus a. Okay, so actually I'm going back and forth here. I'm keep changing my decision. 27a minus a, and 6561 minus 243, right? So that's 26a, and 6561 minus 243, 6318. So therefore a would be 6318 over 26, and therefore a would be 243. And 243 is 3 to the power of 5. And remember, we had made a is equal to 3 to the power of n. So that's 3 to the power of n is 3 to the power of 5, and therefore n is 5. A recursive sequence is defined as t1 is equal to 3, t2 is equal to 4, and tn is equal to half of tn minus 1 plus tn minus 2 if tn minus 1 is even, or tn minus 1 minus tn minus 2 if tn minus 1 is odd, for every integer n greater than or equal to 3. What is the sum of the first 2024 terms of the sequence? We're going to have to calculate the terms and see if there's some sort of a pattern. And the reason I say that is because there's no way you're going to write out that many terms. It would take you absolutely forever. So the hope is that we will see some pattern sooner rather than later. And let's see what happens. And of course, we're going to be using that formula. So here we go. T1 is already given to us, and so is T2. So let's figure out T3. T3, and now how am I going to do that? So T3, we look at the previous term, and is it even or odd? It's even, so then we're going to use that formula. So it's going to be 1/2 of 4 plus 3, right? I'm just going by the formula, nothing fancy here. So then that's a 5. Okay, here we go, T4. T4, we look at the previous term, which is a 5, and this time it's this guy. So that would be 5 minus 4, which is 1. So that's 1. See what I mean? I'm just using the recursive formula here, and I'm not doing anything other than that. So T5 is going to be, well, this is odd, so we're going to use the second formula. So that would be 1 minus 5, and that's minus 4. Keep going here. T6 is going to be 1/2 minus 4 plus 1, and that's minus 2 plus 1, so minus 1. Okay, no, do you see any pattern here? Does anything repeat? Not yet, right? So I got to keep going here, unfortunately. T7, minus 1, minus 4, that's 3. Okay, let's keep going. T8 is going to be 3 minus 1, and that's 4. Okay, I see a pattern now. And let me just do one more here. 1/2, 4 plus 3, that's 5. There we go. So yeah, I see a pattern. It's repeating. So it looks to me like if you keep doing this, this will be 1, this will be minus 4, this will be minus 1, and then this will be 3. Okay, so every 6 it repeats. Okay, that's very helpful. And that's exactly what I had hoped for. So let's see. We want 2024 terms, right? First of all, is 2024 divisible by 6? And I don't think so. No. But I think 2022 is. It's exactly 337. So we have 337 of these groups of 6. Got it? And each group of 6 has a sum. Let's see here. 3 plus 4, 7. 7 plus 5, 12. 13. 13 minus 5, 8. So each of these groups of 6 has a sum of 8. So that we have 337. We have 337 groups of 6. Each has a sum of 8. And then we've got to add the last two. Remember, 2023 and 2024, because those were not included. So just based on the pattern, they would be 3 and 4. That would be the first two terms of a group of 6. So that looks to me like plus 3 plus 4. So when you crunch out these numbers, you get 2703. And that is the sum. Ada writes a sequence of 9 letters using only the letters A, B, C, D, and E. Each letter is only allowed to be followed by some of the other letters as summarized below. How many different possible sequences have A in the first position, D in the 5th position, A in the 9th position? All right. Well, let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have A, D, and A. That's what they told me in this sentence. And then now they want me to figure out how many possibilities. Okay, let's see. Oh boy. What do I do here? So I guess I just have to follow this these rules and kind of see what happens. Okay, let's do that. So A is followed by either B or C. B is either going to be followed by C or E. C is followed by either D or E. C is followed by either D or E. And E is followed by either A or D. D is followed by either A or B, and E is followed by either A or D. Okay, so now we have to have a D there. So that will now narrow things down for us. The only ones that can go to D are C and E. So this one is the only one, and there's nothing in the bottom ones. So that means that, interesting. So that means that this had to be C and this had to be B. So for those guys, it's fixed. That's the only way. Okay, let's keep going here into the other dashes. So D is followed by A or B. So this can be either A or B. A is followed by either B or C. And B is followed by either C or E, correct? Yeah. And then B is followed by C or E. C is followed by D or E. C is followed by D or E. E is followed by A or D. And then we have to go to an A. Okay, so we have to figure out how can we get to an A? We can get to an A from a D or an E. So those are the only ones I got to circle, D or an E. So there's quite a few here. So obviously much more. Wait, there's a D down there as well. E goes to A or D. Yeah, there you go. It kind of looked like a P to me. All right, so that means we got a lot here. Okay, no problem. Now let's list all the possible paths here. So A, B, C, E, and D. That seems to be kind of fixed for those ones, but then it becomes different for the next ones. A and A, that's fixed, but then the middle two are going to be different. B and E, that's one path. The next one, A and A, let's see here, C, D, correct? And the next one, C, E. And then the next one is C, D. And then C, E. And then finally, E, D. So let me just see here. B, E, C, D, C, E, C, D, C, E, A, E. Wait. These ones were not A's. See, this is corresponding to this. These are B's. You gotta make sure I do it all correctly. So let me just double check here. A, B, E, A, A, C, D, A, A, C, E, A, B, C, D, A, B, C, E, A, and B, E, D, A. Yeah, these are the ones. And of course, all of these are preceded by this A, B, C, E, D. So that is the list, and that's 1, 2, 3, 4, 5, 6. So 6 is the answer. A two-player game is played with 12 squares or tiles arranged on the board in 3 rows of 4 tiles each. The two players alternate turns, during which they must remove exactly 1 tile. A player loses if their move causes a remaining tile to share an edge with at least 2 empty squares. The 4 images below, from left to right, represent each state of the board in a game that ended after 3 turns. In order, the first 3 turns were player 1 removed tile F, player 2 removed tile L, player 1 removed tile H. Player 1 lost the game because their second turn caused tile G to share an edge with 2 empty spaces. In the board shown below, tiles C and I have been removed. It is now Ferd's turn. Which tile should Ferd remove in order to ensure that he wins the game? All right, so I assume that you understand this question. So therefore, I will proceed with how to solve it. Now, this guy's name is Ferd, not Fred. All right. So let's see here. Ferd, he cannot remove some tiles, certain tiles, because if he does, he'll lose. And those are A, F, H, and K. Right? Because think about it. For example, if we removed A, then E would share with two adjacent tiles, right? Is that the way they word it? Two empty squares. What did I say? Adjacent tiles? Whatever. So if he removed A, for example, then this E would share an edge with two empty squares. The empty square here and the empty square there when A is removed. So Ferd cannot remove those, because if he does, he loses the game. And that's the definition, I think, that a player loses if their move causes a remaining tile to share an edge with at least two empty squares. So that's established. So these four guys, four tiles, whatever they're called, if Ferd can't remove them, because if he does, he'll lose the game, and we want him to win the game. Okay. Now let's look at other scenarios. What happens if he removes let's see here, let me think about this. Well, to make my life simpler, let me just list out the letters here. A, B, C, D, E, F, G, H, I, J, K, and L. Now, I've already discussed A, F, H, and K, correct? Because if he removes those, he automatically loses. Yeah. So E and I, they were removed already, right? And as you can see, they're not even there. So C and I have already been taken out, so those have already been taken care of. So now we got to look at B, D, E, G, J, and K. Okay, so let's see what happens. If Ferd removes, so let's see, if it B, D, E, G, J, or L, then opponent, let's see what the opponent can do. And then Ferd, what happens? So if the B is removed, the opponent can remove, let's say, something so that the opponent does not lose. Yeah, so for example, if this was an L, that they would not lose. So let me put that in there, because I want you to understand it. It might not be as clear. So if the B is removed by Ferd and the opponent removes L, this is the only thing that's left. E, F, G, H, J, and K. So as you can see, nobody's lost so far, because no letter is shares an edge with two empty spaces. But the very next turn, Fred's gonna lose. Ferd. I don't know why they call this guy Ferd. Just call him Fred. Anyhow, this dude, whatever his name is, he will lose no matter what he selects at this point, because at this point, anything you remove will create a situation where a letter shares an edge with two empty spaces. Try it. You'll see what I mean. So he's going to lose. So the opponent can use strategy. If Ferd removes D, the opponent can then again, let's say J, and that would create a situation like this here. Let's see here. So D and J are gone, so that's going to be A, B, E, F, G, H, K, and L, correct? So that means, same thing, that now it's Ferd's turn, and no matter what he chooses, it's going to create a situation in which he loses. And similarly with E and L, that being removed, if he chose E and then the opponent will strategically choose L to ensure that the opponent does not lose, and then you'll get a situation where only this is remaining. F, G, H, J, K. You got it? And then Ferd has no choice. He's going to lose no matter what he chooses. And similarly, if well, G I'm not sure yet, but J, D would be the one. JD is the same as this guy here, so that's this one. And then L, well, L and B, that's the same as the first one, this one. Yeah. Okay. So it looks like Ferd's going to lose if he selects B, D, E, G, E, J, or L. So let's circle those, B, D, E, J, or L. So by process of elimination, the only one remaining, this is the only possibility that he can move to ensure that he actually wins, stays in the game. For how many angles with x between 0 and 2024 is 4 to the power of sine x squared times 2 to the power of cos x squared is equal to 2 root 2? Well, a very famous equation is sine squared x plus cos squared x is equal to 1. And therefore cos squared x is equal to 1 minus sine squared x, right? So let's see what we can do with this equation here. Let's see here. Well, the first thing, I think I can just move that 2 to the power of 2, and let's just keep that as sine squared x for now. This is 2, so I'm going to substitute that 1 minus sine squared x. 2 to the power of 1, 2 to the power of a half. Get everything in powers of 2 and see if that helps. This then becomes 2 times 2 sine squared x times 2 times 1 minus sine squared x is equal to 2 to the root 3 over 2. And then we can just combine this. It will be sine squared x plus 1 is equal to 2 to the power of 3 over 2. Okay, so that means sine squared x plus 1 is equal to 3 over 2. And where do I go from here? Sine squared x is equal to 1/2. So sine x is equal to plus or minus the square root of 1/2, which I believe is plus or minus root 2 over 2. Okay, so now what we need to do is analyze the graph of sine x. And let's see if I can do that. So let's draw, and x is between 0 and 2024, so there's positive values of x. That's good. So the graph of sine x looks something like this, right? It kind of goes like that and then just continues like that. And then dot, 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 like this. It kind of keeps on going forever. So root 2 over 2 is what? About 0.7 approximately? So when x is 0.7, it looks like here, because this is, hold on, let me think about this for a second. This is 0, obviously. This is 90 degrees. This is 180. This is 270. And this is 360. And then the values for 90 is 1. And then for 270 is negative 1. So 0.7 for the value of sine x would be approximately here. This is 0.7. And negative 0.7 is approximately here. So it's here, 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 and here. You got it? So for every cycle, it's going to be 4 times, 4 solutions. So 4 solutions every 360 degrees. Okay. And what are we going up to? We're going up to 2024. So x is between 0 and 2024. Okay, so how many 360 degree cycles is that? 5, I think, right? Because 5 times 360 is 1800. And then we'd have to go another 2024. Yeah. So for each of these 5 cycles, you get 4 solutions. So 5 times 4, that's 20. And then I have to figure out how many more solutions from 1800 to 2024. So if we extended this sine graph, dot, 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 and this was 1800, then we got to go to 2024. So that would be another 180. And this would be another 180. So that would go to 2160. Yeah. And 2024 obviously is somewhere in here, wherever it is. 2024 would be somewhere here, I think. Okay, so if we look at the graph, we're going to get, in terms of 0.7, we're going to get another one there. Aha, I got to figure out. Okay. I actually have to figure out what was that point on the x-axis. So, which would be similar to figuring out what is that point. Okay, that's not a problem. Just, you can use your calculator. 45 degrees. So that would be basically this point plus 45 would be the next 0.7. So this point is, hold on, I hopefully I did this right. The 1800 plus 180 is 1980. So this is 1980. And then to get to the next point, you have to add 45, and that would be 2025. So this would be 2025 is the next time you get a negative 0.7. So we have 2024. So we're right before it. So we don't actually touch it. We don't actually get to it. So you only have to include these two. Very, very interesting. Because if you just look at it with the naked eye, it seems like we might have one more solution. But when we actually calculate it, we realize that we don't. So we just have 2 more solutions. So we have to add 2 to that 20. So 22. All right. So it took a little bit of thinking, but hopefully got the right answer. Square ABCD has side lengths 14, midpoints of AD and AF are E and F respectively. Points G is on EC such that the ratio of area of FGB to ABCD is 5 to 28. What is the ratio of EG to GC? All right, I'm going to need some lines here. Let me put in those lines. The first one will be from G all the way up to there. The next one, G all the way down. And then the next one, I think, will be G to the other side there. And I think that should be sufficient for now. If I need anything more, I'll add it later on. Okay, and as always, I'm going to put this on a coordinate axis. For some reason, that always works out for me. So let me just continue to use that technique. That's a y-axis. And this is, of course, 0. Now, let's set this up. G is, I don't know, so I'm going to just call it AB, the coordinates of G. And triangle FGB over ABCD, that is what we're trying to figure out, right? The ratio of FGB to, oh, they already give you. So that's not what we're trying to figure out. Well, we're trying to figure out this. EG over GC. Okay, so that's our ultimate goal. Okay, well, ABCD, that's actually fairly simple to figure out because that's just a square with side length 14. So that's 14 times 14. So that can easily help us. That triangle FGB, if you crunch out these numbers, will be 35. Okay. And the triangle FGB, the area is 1/2 base times height. Now the base is 7, correct? Because F is the midpoint. Yeah, so that's 7. Yeah, so that's 7. And the height, basically, since this corresponds to 14, it would be 14 minus B. 14 minus B. So that would mean that, let's see here, 2 times 35 over 7 is 14 minus B. So that's what? 10 is equal to 14 minus B. So B is equal to 4. Okay, not sure if that helps, but I wanted to figure that out. Okay, now let's look at this. I think we're going to use similar triangles here because triangle E, well, I got to label these now. Let's call this H. EHG, that's similar to, let's call this I. GIC, right? Those are similar triangles. So therefore, EG over EH is the same as GC over GI. And most of them, I think we know. This, we can rearrange to EG over GC is equal to EH over GI. EH, well, this is 7, this is 4, so EH would be 3, and GI would be 4. And that's exactly what they wanted. So 3 over 4 is the answer. A function f at x has the property that f at x minus 1 over x is equal to x to the power 3 minus 1 over x to the power 3. For all x that are not equal to 0, what is f at 1? Okay, so we want to put 1 here. So that basically means that 1 over x minus 1 over x is equal to 1. Okay, so we have to solve for this. Get a common denominator. X squared minus 1 over x is 1. So x squared minus 1 is equal to x. X squared minus x minus 1 is 0. Now, unfortunately, this does not factor, so I've got to use a quadratic. I will let you do that. I'm sure you can, and when you do, you'll get x equal to plus or minus root 5 over 2. Okay? When x is equal to either 1 plus root 5 over 2 or 1 minus root 5 over 2, you will get 1 for what's in the bracket. So let's use one of them. Let's just use this one. And let's see what we get. So when x is equal to 1 plus root 5 over 2, it becomes f at 1, right? Because when you substitute this value of x into here, that would turn into 1. That's exactly what we just did here. So then we have to say, okay, then this would be 1 plus root 5 to the power 3 plus, oops, not plus, negative 1 over 1 plus root 5 over 2. Got to make sure I'm putting that 2. You got it? And then when you crunch out these numbers, you get about 4.236 minus 0.236, and this is 4. So that's pretty much all that is. I skipped some steps because I want you guys to do them, because it's fairly straightforward, I think. A computer program points to prints the positive integers in increasing order starting at 1. One integer is the computer printing when it prints the digit 1 for the 1000th time. So we need to make a table here and keep a tally. When you print integers 1 through 9, let's see, the number of ones, we'll keep a tally there. The number of ones is just 1. The 1 only appears once. Then if we print the integers 10 to 19, you will get 10, but for the number 11, you'll get it twice, so you get a total of 11 ones. 20 to 29, you will get only 1. The number 21 has a 1 in it. 30 to 39, again 1. 40 to 49 has 1. 50 to 59 has only one instance where you get the digit 1 printed. Similarly, 60 to 69, 70 to 79, 80 to 89, 90 to 99. Okay, So let's keep a cumulative tally. Cumulative. How many ones are there? Well, that's one. That is, let's see here. 1, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 by the time we get to 99. Okay. Now we're going to get into, we're not even close actually to 1,000th. They want the 1,000th. So we got to keep going here. We got a ways to go. So let's keep going. 100 to 199. And now we get each of those, the first digit is a 1. So you're going to have 100 of the ones. But then if you look at the next two digits, it behaves as what we have up here. So you'll get another 20 from those guys. And that's the great thing about this, is that you can just kind of look at what we did before. So the cumulative total is now 140. Similarly with 200 to 299, the first digit is a 2, so you don't get any ones there. But the 0 to 99 will behave just like these guys. So you'll get a total of 20. So this cumulative goes up to 160. And similarly from 300 to 399, it's 20. This goes up to 180. 400 to 499, 20, 200, 500 to 599, 20, 220, 600 to 699, 20, 240, 700 to 799, 20, 260, 800 to 899, 20, 280, and then finally 900 to 999, 20, 300. Okay, we're up to 300, so that's not bad. Okay, so then we get into 1,000 to 1099. Okay, so then we got to think about this now. The first digit of all of these 100 numbers is 1, so you're going to 100 of these ones. But then from 000 to 099, it behaves like these guys up here. So that's 20. So like that, 120. So that's 120. So we got to add 120 to this cumulative total, so now we're up to 420. Similarly, 1100 to 1199, that's going to be 100 for the first digit, but then the 100 to 199, that behaves like this guy right here. So that's going to be 120. So that's 220. So now we're up to 640. And then 1200 to 1299, the first digit is 1, so you're going to get 100 of those. And then 200 to 299 behaves like this, so you get another 20. So 120. Okay, we're getting up to 760 now. 1300 to 1399. The 1 is the leading digit for those 100 numbers, so there's going to be 100 of those. But the 300 to 399 behaves like that, so you're going to get another 20. So 120. So then 880. Got it? And then 1400 to 1499, you get 100 for the leading digit, and then the remaining numbers will behave like that, so you get another 20. So that's 120. And now we're up to 1,000 exactly. And I guess we had to go all the way to 1499 to get up to that 1,000th one that is being printed. So 1499 is actually the answer to this question. The real number x satisfies x to the power of log 2024 to the base 10 plus 2024 to the power of log x to the base 10 minus 4 times the root of 506 is 0. What is x? Let's make a few substitutions before I tackle this. Let's call that a, and therefore that means a to the power of 10 is 2024. And then log of x to the base 10 is b, so that means 10 to the power of b is x. Got it? So when I make these substitutions into here, it should make things a little bit nicer. Let's see here. We have x to the power of a. Oh, sorry, hold on. X itself is 10 to the power of b, all to the power of a, plus 2, and then plus what here? Oh, a to the power of 10, all to the power of a. And let's just put this all on the other side, 506 like that. And then this just becomes 10 to the power of AB plus 10 to the power of, hold on here, I think I made a mistake. 2024 is, sorry, this should have been 10 to the power of A. Sorry about that. Yeah, I think I got a little confused there. So that's 10 to the power of A, actually. Yeah. 10 to the power of A to the power of B. Yeah. Because this log x to the base 10 is B. Okay, so then that becomes 10AB. Hopefully you understood there what I did. That's a good thing I caught it. Okay, so then that becomes 2 times 10 to the power of AB is equal to 4 root 506. Is there anything we can do here? Well, the only thing I can think of is just divide through by 2. Okay. So at this point, what happens? I think I have to use logs. I have no choice. So I have to take the log, and I'm using base 10 now. I won't put in the 10, just assume it. So we got that is equal to log. Now you can use your calculator to figure this right side out. That's going to be about 1.6531. And the AB comes out front, and the log of 10. The log of 10 is just 1, so that just becomes AB is equal to 1.6531. And A actually is a number. It's the log of 2024 to the base 10. So that means I can actually get a numerical value for B. When log of 2024 is about 3.30621, so 1.6531, and therefore B is, if you divide through, will be about, is exactly 0.5. So therefore x, which is 10 to the power of B, is 10 to the power of 0.5, or another way of writing it is root 10. Square ABCD has side length 6. The midpoints of AB, BC, CD, and AD are E, F, G, and H respectively. E, H, and F. H intersect at P. A circle of radius 1 is drawn randomly so that it is entirely inside ABCD. What is the probability that the circle intersects the interior of exactly 2 of the line segments EP, FP, GP, and HP? So, assuming you understood the question, the first thing I have to do is draw a diagram that is obviously the same, but there's something I need to illustrate. That is, we need to understand where the circle has to be. Now, the circle has a radius of 1, right? So the diameter is 2. So the radius is 1. So that means the diameter is 2. So I can draw circles like this, touching like that. They're supposed to touch the edges. So just picture them touching the edges. And these are all with diameter 2. Because this was 3 from here to here. So this is from here to here is 2. And if that's the center, that's 1, and that's 1. Now, none of these satisfy our conditions because the condition is that, like this, it has to cross over 2 of those lines. In that case, it's crossing over GP and HP, exactly 2. But none of these here. But they have to be close to that, because if they go out into this territory here, that territory, then they're never going to cross the GP. What are those? The line segments GP, HP, EP, or FP. Yeah, those line segments will never be crossed if they go out into that red territory. So they've got to be at least there, and then once they move, they'll be able to cross over eventually. If they, like, for example, if this first circle here, let's just call this guy, well, this circle that I'm putting a dot in, if that circle moves down a little bit and then moves to the right a little bit, it'll be like this scenario. So I wanted to first illustrate that. So the probability is going to be some specific condition over the total. Now the total is really the area of this guy, because everything else, it's not going to be even possible. So the area of that is pretty simple. It's just a 4x4 square. And then we have to figure out what are the actual places where the circle needs to go. For that, I'll draw another diagram of the same kind of thing. So this time I draw a square in the middle, and that has a circle, the same circle, unit circle, but it's right directly in the middle. Now this one violates the terms because it crosses all four, and we want it to cross exactly two, only two. So it has to move up. It eventually has, for example, that's an example of where it has to go. And in particular, the center of the circle, which I'm kind of putting as that red dot, that has to move out far enough so that it no longer crosses 4 or 3. It has to cross 2. And the example that they drew up here, that I keep pointing to, is an example. See, the center is here of that circle is approximately here, and you can see that it had to move to there in order to cross exactly 2. So in this diagram, that is represented really by these regions right here. Those regions. And those regions are basically the square, which is a 2x2 square, minus the area of that circle, which is pi r squared, and where r is 1. That's 4 minus pi over 16. And that is the answer. And really what you're doing is you're sort of chasing the center of the circle. Where is the center of the circle going to be? And depending on where the center of the circle is, it will either satisfy the conditions or fail the conditions. A 6x6 grid has a coin in each of its 36 cells. Each coin is showing either a head or a tail. Samar notices that in each row, the number of coins showing a head is even, and in each column, the number of coins showing a head is even. In how many ways can the coins be arranged so that this is true? So let's see, we have a 6x6. Let's draw a 6x6 here. Okay, I think that's sufficient. And the number of, what is it? Heads, right? Number of heads. Even in each row, the number of coins showing a head is even. So it can be either 0, 2, 4, or 6. Remember, 0 is an even number. Same thing, 0, 2, 4, 6, 0, 2, 4, 6, and so on. And let's see. So if we have 0 heads, that means from the 6 choose 0, and that is just 1. There's only one way of doing that, basically putting all tails. 2 heads, 6 choose 2, that is 15. 4 heads, 6 choose 4, that's also 15. And 6 heads, from 6 choose 6, that's 1. So if we add up these guys, that's 32. So there's 32 ways of arranging each row so that it has an even number of heads. So I have 32, 32, 32 ways like that. But this question is kind of tricky because when we get to the final row, it's not 32. Well, why not, right? Well, I'll explain. So the first 5 you count, and then we discuss the last row. So the first 5 is fine. The first 5 rows, it's 32 for each, so 32 to the power of 5, right, basically. But then the last row, that's when things are not 32 anymore, and I'll explain why. The answer is actually 1. You say, well, why is it 1? I'll give an example. Let me just draw this again. I don't want to make the diagram up there messy. Okay, so let's say we have a scenario where each row had an even number of heads. So let's just say that has 2 and the rest are tails. This is just an example. And let's say that's 2 also, the rest are tails. This is 4, let's say, which is an even number. Next row has 0, let's say, but that's an even number also. Next row, 2. And then now we will talk about the final row. Remember, the question also says that each column has an even number of heads. In each column, the number of coins showing a head is even. So that means that these columns, this one and so on, have even. Now let's say the first column has 2, so this has to be a tail, because we want to retain 2 and not put a third, because third would make it 3, which is odd. The next column only has 2, so that's going to be tail. This next column has 3, so that has to be an H in order to have 4. This one is going to be a tail, H, tail. So basically what that means is that there's only one way for the last to arrange the last row, or to fill the last row, to arrange to fill the last row. So whatever you have, whatever scenario you have in the first 5 rows, the last row will have only one way. So instead of that 32, it's actually 1. And that's I guess the tricky part of the question. So the first 5 rows is 32, the last row is 1, and that's the total number of arrangements. And 32 is what, 2 to the power of 5? So 2 to the power of 5 to the power of 5, so that's 2 to the power of 25. And that's, I guess, one way of writing that number. A cone with a circular base has A on the circumference of its base, C at the vertex, B on the AC on the surface of the cone, so that its height above the base is 3 root 7. Circumference of the base of the cone is 3 pi, and the circular cross-section through B parallel to the base has circumference of pi. A path is drawn on the surface of the cone from A to B that wraps around the cone exactly once. If P is the shortest possible length of such path, what is P squared? Well, the circumference of A is 3 pi, and since the circumference is pi times diameter, the diameter is 3. And then similarly, the circumference of B is pi, and that's pi d. So therefore, that d is 1. So this is the diameter of, this was the diameter of B is 1, and this is the diameter of A. All right, now what's next here? Let's see here. Well, I think I'm gonna, I don't want to mess up the diagram. I'm gonna draw it on the side here. Yeah, because the way the diagram looks is nice, so I don't want to mess it up. So let me just draw another one here. Similar, the exact same diagram. Just want to illustrate it. Okay, so if that's the center and that's the center, then let me just draw these lines here. So we had the diameter of A is 3, so that means from here to here would be 3 over 2, 1.5. The diameter of B is 1, so that means from here to here is 1, the radius. So this is 1, so therefore this part would be 0.5. Yeah. And this I will label D, this point right here. So AD, hold on, let me see if I did that right. D, the diameter of B is 1, so this is actually a half. Yeah, so therefore that actually is not, it's 1 actually. Yeah, that is equal to 1. So that means that a to d is 1. Okay, so then we can use Pythagoras. AB squared is equal to AD squared plus BD squared. And then AD squared I just figured out was 1. BD squared they gave me in the question is 3 root 7. So that looks like what? 9 times 7, 63, 64. So that basically means that AB is equal to 8. Okay, AB is 8, and that is good. And then this point right here I'm going to call E, and this point here, let's see here. Well, I'm going to stretch it all the way to the top. So all the way to the top like that. So triangle AEC is similar to triangle ADB. So that means that AC over AB is the same as AE over AD. AC over AB is the same as AE over AD. Yeah. So that means we have AC over 8 is equal to, what's AE? 3 over 2 over 1. So when we solve for this, we get 12. Okay, so that means this would be 4 then, since that whole thing is 12. Okay, so moving right along. So now what we need to do is we actually need to, we have to figure out the path for P, but the only way we could do that is to open it up. And let me explain what I mean. I'm going to need some space here. I got to open this up. So I've got to take this cone and I've got to open it up. So like if I were to cut down the middle like this, and when you open it up, it'll actually look like this. Like that. That's what it looks like. So this is this time the A. Here was A and C, and this is A and C now. And the B is going to be somewhere here on both sides. And we are actually, when we use the shortest path, it'll be like from there to there, from 1A to 1B on the other side, not on the same side. Yeah. And then we know that AC is 12. We just figured that out. So that side is 12. Yeah. ABC, got it. And then A to B, that represents P. So we can use the cosine law. P squared would be AB squared plus, let me think about this for a second. Well, yeah, P squared is AB squared actually, because P is representing AB. And that is AC squared plus BC squared minus 2 times AC times BC times the cos of angle ACB. Okay, so all of these I think I have except that angle. So let's see here. AC is 12, so I have that. BC, what's BC? BC was 4, right? Yeah, B to C was 4. And that's certainly not drawn to scale, but that's okay. And then minus 2 times 12 times 4, and then the cos. Oh yeah, the cos of that angle. Okay, so the angle I have to figure out. Okay, so that, I got it. Okay, so let's talk about this angle here. That angle is ACB, right? Okay, I got to figure that out. How do I do that? From here to here, that is the equivalent of the entire circumference, right? So that was the circumference of the bottom. We did that. That was actually given, I believe, It's 3 pi. Yeah. So that means that if this is also, that arc AA is equal to 3 pi. Yeah. Yeah. And if you kind of look at this sort of like a circle all the way around, where C is the center, the radius would be CA, right? CA, which is, or AC. Sorry, I should have wrote wrote 8C. Well, you guys understand. AC, CA, same thing as 12. So that is a circle with radius 12. So if the radius is 12, that means the diameter would be 24. Correct? And the circumference, therefore, would be 24 pi, because the circumference is equal to pi times the diameter. So that means this arc, AA, over the entire circumference is 3 pi over 24 pi, which is 1 over 8. So that means that angle is 1/8 of the total angle, which would be 360. So that angle ACB is 1/8 of 360, which is what? 180, 45 degrees. So that 45 degrees is what goes in here. Okay. And then when you crunch those numbers out, you will get, let's see here, 144 plus 16, so 160. And then we have 24 times 4, which is 48. Wait, hold on. 24 times 4 is not 48, it's 96. So minus 96. And then close to 45, I believe, is root 2 over 2. So it would be 160 minus 48 root 2. So that is the answer for p squared. For which positive real numbers a does the polynomial have exactly 2 distinct roots? 2 distinct real roots. The first thing we need to do is factor that. And when you do, you will get x squared plus 1 minus ax plus 1 minus a for the first factor. And for the second factor, we have x squared plus 1 plus a plus 1 plus a, like that. And the roots, if we look at these guys, the roots here would be, oh, you're going to have to use a quadratic. Yeah, so it'll be minus b plus or minus the square root of b squared minus 4 ac all over 2, which is, I guess if we rearrange it, a minus 1 plus a plus 1 squared minus 4 over 2. And this is the discriminant here. Discriminant. And that's going to be, let's call that one D1. And in a very similar way, for this guy, the roots, again, we're going to have to use a quadratic. Minus b plus or minus the square root of again, when I expand and arrange it, it'll be a minus 1 squared minus 4 all over 2. So this is the other discriminant. We'll call that D2. Okay, so now the original polynomial, this guy, will have only, what are they asking for? 2 distinct roots. So p at x we'll have two distinct roots, two distinct real roots actually, if we have the following scenario. This is, let's say, quadratic 1, this guy, and this one is a quadratic 2. So it's if quadratic 1 has, let's see, either two distinct real roots, and quadratic 2 has 0, that's one scenario. Another scenario is this one has 1 and 1, and final scenario is this is 0 and that's 2. Yeah, because we want a total of 2 distinct real roots. So those are the scenarios, and we're going to have to work with each of those scenarios. Okay, so hopefully I can keep it on one page. Yeah. All right, here we go. So the first scenario, actually, let's see, which one do I want to tackle first? I'll do this one here, because the one root means that the discriminant is equal to 0. So situation 2, that means discriminant is equal to 0. Okay, so the first discriminant that I circled in red, that's a plus 1 squared minus 4. And if that's 0, that means that a plus 1 squared is equal to 4. A plus 1 is equal to plus or minus 2. That means a is equal to either 1 or negative 3. And then similarly, the D2, the second discriminant, which is a minus 1 squared minus 4, that has to equal to 0. A minus 1 squared is 4. A minus 1 is equal to plus or minus 2, and therefore a is equal to either 3 or negative 1. So there's no solution here. No solution. See, there's nothing in common in those two. Okay, so that means that this scenario fails. So we can only find a hope here, either with this guy or this guy. So let's do 1 here, and we'll do 3 here. So 1 means that the first quadratic has 2 solutions. So that means that its discriminant is greater than 0. And the second quadratic has 0 solutions, 0 real solutions. So that means that discriminant is going to be negative. Okay, let's see what happens. So this would mean a plus 1 squared is greater than 4. A plus 1 is greater than 2. Or a plus 1 is less than 2. That means a is greater than 1, or a is less than, minus 2. A is less than minus 3. In the next one, this would mean that a minus 1 squared is less than 4, and therefore a minus 1 is either less than 2, or a minus 1 is greater than minus 2, and therefore a is less than 3, and a is greater than negative 1. Now the common solution to this is a is between minus 3 and 1. Yes, greater than negative 1, greater than minus 3. Yeah, that's the common solution. Okay, so we got one more. Let's see if we get anything. This is where this scenario here, where the first quadratic has 0 the real solution, so that means its discriminant must be less than 0, and the second discriminant is going to be positive, since we want 2 solutions for that one. So this will give me a plus 1 is less than 4 squared, I should say. So a plus 1 is less than 2, or a plus 1 is greater than minus 2. Therefore a is less than 1, or a is greater than minus 3. And the next one be a minus 1 squared is greater than 4. So a minus 1 is greater than 2, or a minus 1 is less than minus 2. A is greater than 3, or a is less than minus 1. So if you combine these guys, this one and this one, what do I get here? The combination would be minus 3 is less than a, less than minus 1. So what do they want? The positive real number. So a is positive. So since a is positive, that means this is the only solution that is valid.